Hello, and welcome to another Algebra 2 lesson. This is lesson 8.5. The objectives: evaluate recursive rules for sequences, write recursive rules for sequences, translate between recursive and explicit rules for sequences. The rules we were writing earlier in the chapter, those are actually called explicit rules. An explicit rule gives a sub n as a function of the term's position number n in the sequence. A recursive rule gives the beginning term or terms of a sequence and a recursive equation that tells how a sub n is related to one or more preceding terms, using a sub n minus 1 to represent the previous term. Write the first 6 terms of the sequence. Example 1a. A sub 0 is 1. A sub n equals a sub n minus 1 plus 4. So they gave us a sub 0, so the next one would be a sub 1, would be the previous term, that would be 1, plus 4. So a sub 1 is 5. A sub 2 is the previous term, a sub n minus 1, so that'll be the 5 plus 4. So a sub n minus 1 represents the previous term, so you have to take the term right before the one you're working on and put it in here. So we get 9. And we want to find 6 terms, so a sub 3, a sub 4, a sub 5, and a sub 6. So now that we get the pattern, it's up to you if you want to show as much work or not. I'll show the long way one more time. So we take your previous term, that's 9, and add 4. 13. Take 13, add 4, add 4, add 4. And there's your first 6 terms. Let's try 1b. Using a little different notation here, they have f of 1 equals 1. And then we'll find f of 2, 3, 4, 5, and 6. F of 2 says f of n equals 3 times, this is representing the previous term, f of n minus 1. So that's the term before the nth term. So 3 times the previous term. Three times the previous term. Let's do it the long way one more time. So f of 4 is 3 times the previous term. So all we're doing is multiplying by 3 each time. So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3. 81. 81 times 3. So we start with 1, and then you multiply by 3 each time. So 1, 3, 9, 27, 81, 243. This first one It was previous term plus 4, but we started with 1, so 1 plus 4 is 5. 5, 9, 13, 17, 21, 25, adding 4 each time. So these are recursive rules when we use the previous term and just say, what are we doing to the previous term? This one was the previous term plus 4. This one was previous term times 3. Do the given graphs represent arithmetic or geometric sequences? Okay, arithmetic is when you were adding to get to the next number, and those are the ones that showed up as linear expressions or equations. So that's this one, straight line. This is the arithmetic. And geometric is when we're multiplying by numbers, so that goes up faster, 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 faster. So this is the geometric. Okay, keep in mind that's what their graphs are supposed to look like. They are just dots because we're only using the integers, x is 1, x is 2. We don't have any of those numbers in between, so we don't connect them. These are called discrete sets of numbers. They're not continuous. Writing recursive rules. In part A of example 1, the differences of consecutive terms of the sequence are constant. So the sequence is arithmetic. In part B, the ratios of consecutive terms are constant, so the sequence is geometric. In general, rules for arithmetic and geometric sequences can be written recursively as follows. Arithmetic sequence, a sub n equals a sub n minus 1 plus d, where d is the common difference. Geometric, a sub n equals r times a sub n minus 1, where r is a common ratio. Remember that a sub n minus 1 represents the previous term. That is the term right before the nth term. 1 before the nth term, n minus 1. Write a recursive rule. When you write a recursive rule, you always have to say what your starting number is. So we are starting, a sub 1 is 3. We're starting with 3, and what do we do each time? Add 10. So our d, our common difference, is 10. So our rule will be a sub n equals the previous term. How do we say previous term? The one that comes before n. A sub n minus 1 plus the common difference, 10. Now, this rule, if you do not say what to start with, means nothing. You have to have the first term and this rule. Because if you just say add 10 to the previous term, but don't say what the first term is, you don't know where to start. So you need both. All right, example 2b. Well, we're not adding the same thing each time. Can we get from here to here with multiplying? Let's see if there's a common ratio. If we take a number and divide it by the previous number, we'll get the common ratio if there is one. 625 divided by 250 is 2.5. Now we have to see if we get the same thing for the other ones. 250 divided by 100. Yep, that's 2.5. 100 divided by the term before that one, 40. That's also 2.5. And then 40 divided by 16 is also 2.5. So that is our R. That's our common ratio. And we also have to state our a sub 1. So a sub 1 equals 16. That's our starting number. Once you know the starting number, you can take the starting number multiply it by so a sub 0 is 1, a sub n is n times a sub n minus 1. That's what they did. Now, I did it a little different. I let a sub 1, I did this as the first term, second term, third term, fourth term, fifth term. So if I'm using these, then we would have to say n minus 1 times the previous term but where this falls apart is if you were doing a sub 2, you would do 2 minus 1 is 1 times the previous term. Yep, that would work. A sub 2 is 1. Previous term 1 times 2 minus 1 is 1 times 1 is 1. And then let's check it for a sub 3. Does this still work, or do we have to use their version? A sub 3 would be this one. So 3 minus 1 is 2 times the previous term is 2 times 1 would be 2. Is a sub 3 2? Yep, that's working. So once you've got a rule that you think is working, try it out and see. So this is another possible answer. Big Ideas wanted this one, though. So they used an a sub 0 with that one. Made this the 0 term and then the first term. All right, and that's example 3. Example 4, translate from explicit rules to recursive rules. Write a recursive rule. This one, a sub n equals negative 6 plus 8n. This looks like a linear equation, so this is an arithmetic sequence. This one has a variable in the exponent, so this is a geometric sequence. It's important that we take the time to think about that. Then we know what kind of rule we're writing. Write a recursive rule. So we need to know a sub 1 would be negative 6 plus 8 times 1. So what's a sub 1? A sub 1 is 2. Okay, we don't have to state what a sub 2 is, but I'm going to find it just so that we know what the sequence looks like. Negative 6 plus 8 times 2. 16 minus 6 is 10. So notice this number here, the 8, we are getting 8 more each time. We are adding 8. So that's our D. That's our common difference. Our common difference is 8. We know a sub 1 is 2. So our rule as a recursive rule is previous term, add 8, add 8, add 8. So a sub n minus 1. Remember the n minus 1 is a subscript written smaller and lower. Plus 8. This rule, without saying what number to start with, means nothing. So you have to state a sub 1 also. Let's try the next one. The explicit rule for a geometric is a sub n equals a sub 1 times r to the n minus 1. So a sub 1 is -3. R is 1/2. For a recursive rule that we're writing, we have to state a sub 1 as part of our answer, but then we also have our a sub n equals the previous term times r, which we usually write as the r first, times a sub n minus 1. Include your starting number, and you have your answer. So let's think about this rule we just wrote. This says start with -3 and then multiply by 1/2 each time. -3 times 1/2 would be -3/2, and then multiply by 1/2 again. That would be -3/4. And then if you generate the numbers in the sequence using this rule, you would need to get the same set of numbers. So it's two different rules to describe the same set of numbers. And that was translating from an explicit rule to a recursive rule. Number 5, translate from a recursive rule to an explicit rule. So now we're going the other way. Whenever you learn something in math class, you will almost always have to learn how to do it backwards. When we learned how to add, eventually we learned how to subtract. When we learned how to multiply, we learned how to divide. So if we're going from explicit to recursive, we also have to go from recursive to explicit. So here's our a sub 1. And our a sub n is a sub n minus 1 minus 2. So previous term minus 2. So we're subtracting 2 each time, so that's the d. That's the common difference. D equals -2. A sub 1 has to be part of our answer. -5. And then the rule is previous term minus 2. Previous term minus 2. For the recursive rule, we need the explicit rule. So back to the formula we learned several days ago. A sub 1 plus n minus 1 times d. Put in your a1 and your d and simplify. Make sure to simplify. Final answer, a sub n equals -2n minus 3. We now know this as an explicit rule for a sequence. At the beginning of the chapter, it was the only rule we knew about. All right, try another one. A sub 1 is 10. We're doing 2 times the previous number. That's the recursive rule. We need an explicit rule. So r is what we're multiplying by each time, so that's 2. The explicit rule in general for a geometric, which is what this one is because we're multiplying for a geometric sequence, is a sub n equals a sub 1 times r to the n minus 1 power. So a sub n equals, a sub 1 is 10. A sub n equals 10 times 2 to the n minus 1 power. All right, and that's example 5. Here's a summary of your formulas, and this is what you need to know for Big Ideas Assignment 8.5. Write down this summary of your rules, please. pause it here and write these down. This is a great summary page.